Friends, welcome to my YouTube channel. In this video lecture, I'm going to answer questions from Secondary Surveillance Radar of Keith Williams Radio Navigation book. So in the previous lecture, I solved or answered SSR-based questions from Oxford Radio Navigation book. In this video lecture, I'm going to answer all questions from Keith Williams Secondary Surveillance Radar chapter. Very important chapter, especially for ATPL exams. So let's start. Question number 1. When Mode C is selected on aircraft secondary surveillance radar transponder, the additional information transmitted is what? So very important. There are three main modes: Mode A, Mode C, and Mode S. So Mode A transmits the identification of aircraft. Mode C works along with Mode A. So identification will be there, plus additional information is altitude information. Now this altitude is based on pressure level, standard pressure level 1013. Next, Mode S. This Mode S enables data link communication between ground station and aircraft transponder. Okay, remember this. So when Mode C is selected on aircraft SSR transponder, the additional information is altitude based on QNH, aircraft height based on subscale, height based on QFE, flight level based on 1013.25 hectopascal. Option delta is the right answer. So irrespective of your sensitive pressure altimeter setting, the vertical distance reported by Mode C capability will be flight level based on standard pressure setting 1013. Remember. Question 2. Ground secondary surveillance radar equipment incorporates a transmitter and receiver respectively, operating in what band, operating on what frequencies. So remember this. Let's say this is your ground station or secondary radar situated on the ground. Here is your aircraft. Okay. Now secondary surveillance radar operates on two different frequencies. Unlike primary radar, secondary radar operates on two different frequencies. Primary radar will operate on one particular frequency throughout its operation. The frequency at which it transmits a pulse, a radio pulse, will be the same frequency at which it will receive that pulse. But in case of secondary radar, it will transmit a radio radar pulse on one particular frequency, and it will receive that pulse from aircraft on a different frequency. But there is a twist. I'll explain that to you. Now, the frequency at which this pulse is transmitted towards the aircraft is always 1030 megahertz. When this pulse strikes the aircraft, the transponder in aircraft will reply to this pulse. It will send its own peculiar, its own unique energy, unique information, or unique pulse. This information or this reply pulse will be sent back at a frequency of 1090 megahertz. So the transmitted pulse is called interrogation pulse. Pulse replied by aircraft will be called reply pulse or transponded pulse. Transponded pulse. The ground antenna will be called transmitter. It would be more appropriate to say an interrogator. And in aircraft we have a transponder. So two different equipments for two different purposes. One for transmission and another for transmission from aircraft. Okay, so remember always ground stations 1030 and transponders 1090 megahertz. So your aircraft will always transmit at 1090 megahertz and ground will always transmit at 1030 megahertz. Now, a ground station can also be a transponder. Aircraft can also be an interrogator. Okay, so irrespective of their roles, the frequencies at which they transmit are going to remain the same. Aircraft is higher, it flies at a higher level than the ground. So the number that belongs to it will be also higher than 1030. Remember like that. So ground 1030, this is 1090 by aircraft. So answer here. Now here they are talking about ground radar that incorporates a transmitter and receiver. So a ground radar. Now this ground radar will always transmit at 1030 megahertz. Okay, at 1030 megahertz, and it will receive at what? So 1030 megahertz, and it will receive a frequency of 1090 megahertz. Okay, very simple. And always remember 1030 megahertz can be plus minus zero point 0.2 plus minus zero point 0.2 megahertz, and this 1090 megahertz can be plus minus 3 megahertz. Next, question 3. Why is the secondary radar display screen free of storm clutter? Free of storm clutter. It is free of storm clutter because, as you can see, it does not use echo principle. What is echo principle? In case of primary radar, let's say this is your radar antenna, radar primary radar, and here is your aircraft. Okay, so it will transmit a radio pulse or radar pulse in the direction of this target. This radio pulse will strike the target and come back at the receiver. Now, in case of primary radar, the transmitter as well as the receiver is going to be the same. Okay, transmitter and receiver is going to be the same. So it operates on the basis of or on the principle of echo principle. What is echo? Echo is nothing but reflection. So whatever radar pulse you are sending, that gets reflected from the target aircraft. So that's why we call it echo principle. Now, because of this echo principle, if there are any large water droplets in the atmosphere, okay, large water droplets in a CB cloud, cumulus cloud, any storm cloud, okay, so this water droplets can also create reflections, and these reflections will also be shown on the radar screen. This is the exact idea on which airborne weather radar operates. It also operates on the basis of primary radar principle. It transmits a radio wave in the direction of a target, a cloud, okay, and if there are large water droplets suspended in that cloud, those large water droplets will reflect or send that radio energy back to the airborne weather radar, and then you will get to see different colors corresponding to different sizes of water droplets. So that's why we use echo principle in case of primary radar, and this echo principle can also generate reflections or returns from water droplets in the atmosphere apart from aircraft. But in case of secondary radar, we do not use echo principle. The ground station will transmit an interrogation pulse towards the aircraft. The aircraft will reply or answer to that pulse by sending its own information, its own unique pulse of radio energy. Okay, so there is no idea or there is no concept of echo in case of secondary radar, and that is why the transmitted frequency and reception frequencies are different. Since the frequencies are different, there is no place or there is no concept of any kind of echo or reflection generated from any large water droplet in the atmosphere. So that's why is it free of storm clutter? The principle of echo return is not used in secondary radar. It's not used in secondary radar. Question 4. In order to indicate radio failure, what is the transponder code that is to be selected? So for radio failure, it is 7600. Distress or emergency, it is 7700. For hijack or unlawful interference, it is 7500. That's it. These are the three main codes that you have to remember. Question 5. In order to indicate unlawful interference with the planned operation of flight, the aircraft SSR transponder should be selected to 7500. When aircraft is operating its SSR in mode C, ATC presentation gives information regarding aircraft's flight level that is accurate to within what? So the correct answer is plus minus 50 feet. Let's say your aircraft is flying at a flight level. Let's say it is flying at a pressure altitude. This is your standard pressure setting datum 1013. And now pressure altitude of your aircraft is 17,600. 17,600. It is 17,560. Now this 17,560 is an accurate value at which your aircraft is flying. Okay, accurate pressure altitude value at which your aircraft is flying. Now the information sent by mode C capability of your transponder to your ATC controller will be not exactly or will not be accurately 17,560. The information given by mode C capability will be 17,600. Okay, so it will round off the figure. Okay, now let's say your pressure altitude is equal to 17,520. In that case, mode C capability will transmit information, altitude information of 17,500. So 520 has been rounded off to the nearest whole number 500. 560 becomes 600. That means any number which is less than 50 feet, 17,550. So any number which is less than 17,550 will be reported as 17,500 feet. Any number which is more than 17,550 will be reported as 17,600 feet, right? So the values sent to the ATC controller are rounded off to the nearest whole number. So this numbers, now as you can see, 17,560 is given as or transmitted as 17,600. So the accuracy is how much? The difference between the accurate value and transmitted value is plus minus 40 feet. It is plus 40 feet. Okay, plus 40. In case of 17,520 and 17,500, the accuracy is minus 20. So the maximum difference that can occur between a transmitted value and accurate value is plus minus 50 feet. Plus minus 50 feet. Okay, so they are talking about accuracy. So accuracy will be plus minus 50 feet. So although mode C capability may be telling ATC controller that your aircraft altitude is 17,600, there may be a possibility that accurate value or the exact pressure altitude you are flying may be less than 17,600. It can be 17,580, 17,590, anything less than 17,600. There may be a possibility. Okay, and all altitudes are reported in increments of plus minus 100 feet. Okay, in terms of 100 feet, like here 17,500, 17,600. So if they have asked about accuracy limit, select plus minus 50 feet. If they are talking about reporting in terms of increments, so that is going to be plus minus 100 feet. Okay. Question 7. The frequency of ground transmission, SSR ground transmission, is very important. I wrote it here. See, For ground transmission, ground frequencies is always going to be less than aircraft because ground is at a ground level, aircraft is higher than the ground. So ground frequencies will be 1030 plus minus zero point 0.2 megahertz. So SSR ground transmission is 1030 plus minus zero point 0.2 megahertz. Important. Question 8. The two main design functions of SSR mode S. They are talking about mode S, selective. S stands for selective. SPL Viva question. So mode S are what? Collision avoidance using PCAS2 and improved long-range communication capability, continuous automatic position reporting using GPS and collision avoidance using PCAS, elimination of ground-to-air communication, and introduction of automatic separation between aircraft using PCAS, air-to-ground, ground-to-air data link communications, and improved ATC aircraft surveillance capability. So the correct option here is the most appropriate option, option delta. With the help of mode S, mode selective, the ATC can establish data link communications. Data link communications means the information will be transmitted and received between aircraft transponder and ground interrogator automatically without having the pilot report any kind of information verbally to ATC controller. So this relieves the pilot of any kind of workload. It relieves ATC workload also. Okay, it establishes efficiency and facilitation happens. Okay, so that's why air to ground and ground to air data link communications can happen automatically, system to system. Okay, the mode S capability of a transponder can transmit many pieces of information to ground interrogator, like the flight level you're flying at, aircraft identification, flight level, wake turbulence category, your ground speed of aircraft, the okay, so this and many more pieces of information. So that's why. And second design function is improve ATC aircraft surveillance capability. So when the ATC controller has so many pieces of information or is exposed to so much new information from every aircraft, he can use that information to his advantage and do his job in a better way. Okay, and therefore his surveillance capability. The surveillance means monitoring, supervision increases. So that is another added advantage of mode S capability, that air to ground data link communication, yes, and improve ATC aircraft surveillance capability. Now here we can also use mode S capability in a transponder to coordinate avoidance maneuvers between two aircraft detected by your TCAS equipment. So mode S capability is what gives coordinated maneuvers or coordinated resolution advisories to two aircraft at one time. Your aircraft will receive a climb resolution advisory or uh, a climbing command, and another aircraft, another traffic which is in front of you or which is on a collision course will receive at the same time a descent instruction or a descent command. So these commands are coordinated. Okay, they are coordinated and simultaneously given to both aircraft, and this happens because of mode S capability in your transponder. So that part is correct. But the second part, improved long range communication capability. This is not a function of mode S. This is actually a function of ADSB, automatic data surveillance. Okay, with this, you can establish communications over oceans also with the help of satellites. So that is with the help of satellites, not mode S. So that's why that's wrong. Next, other options, Bravo and Charlie are very wrong, are irrelevant. Okay, TC transponder system excluding mode S contains how many codes? Four codes, two modes, correction, four modes, two modes each of 1024 codes. So there are, excluding mode S, there are two modes, mode A and mode C. and mode A has a number of 4096 codes. So Bravo is the correct option. 10. A secondary radar can provide up to 4096 different codes. These codes can be used in all modes: mode A, mode C, mode S. So answer is all modes: mode A, mode C, and mode S. Now mode S also accepts codes or interrogations coming from or meant for mode A and mode C. This has been done to establish or to have an easy transition from mode A mode C system to a new technologically advanced system of mode S. So mode S has the capability to accept the functions of mode A and mode C. So indirectly, all modes can use this 4096 codes and additional new codes belonging to mode S. This concludes our lecture. I hope you have understood all the 10 questions, the answers I gave, the explanations I submitted. So keep practicing these questions. Read the chapter, read the theory, read also from Wikipedia. This SSR is very relevant to our ATPL's airline exams and practical flying. So the more knowledge you have of this, more relevant knowledge you have, the better your flying will be, your flying experience will be. So I wish you all the best, and I request you all to share this video with all your friends who are preparing for exams. And do hit the like button if you have liked this video lecture. If you have not liked it, hit the dislike button. I'll see you in the next video lecture in which I will solve the next 10 questions. See you.